Hello all, and thank you for coming to this inaugural webinar on topography and wave. I appreciate you all coming out and attending. Hope that this stuff will be interesting to you and hopefully give you a little bit of a foundation as to moving forward with wave and being able to apply it clinically more effectively. A little bit of the housekeeping out of the way. I am a consultant for Oculus and Wave, private practice. I'm in solo private practice, and my practice is pretty much 100% contact lenses. I deal with irregular corneas as a major part of my practice. Anything else is pretty much ortho-K. I have very, very few normal, boring primary care type of cases that I take care of. I previously did national clinical support for Wave on case-by-case basis. I've put together lectures and webinars for Wave users. I also offer private practitioner consultation services, and that goes through a few avenues. I'll go through that. There's a little slide at the end that'll give you a little bit more information if you're interested in obtaining my help for some of that, both remote fitting and the telemedicine. And I do beta test, both for the CSP and the Wave, and I'm currently working with the AXL Wave software and trying to get that software as developed as possible for us fitters, not just for cataract surgeons. I also put together the first Wave Designers program, and I'm guiding Wave training, including through these webinars such as tonight. All right, so a couple of questions I want you to ask yourself and be truthful to yourself as to how you'd answer these questions. Are you new to Wave, for example, 6 months or less? Have you already sent in cases for clinical support because things didn't go quite like you expected them to? Are you relatively new or new totally to gas perm fitting? Are you new or relatively new to ortho-K and or myopia management? Are you relatively new or new to scleral lenses? These are all some of the hottest topics right now today, certainly especially lens fitting, and it tends to draw people into Wave. Are you comfortable fitting lenses empirically? A lot of doctors have really come from a trial lens background. I have not put a trial lens on a patient probably for close to 20 years, and I'm enjoying the fact that I don't have to do that. It's much more efficient, and the patients actually prefer it better, but this is a very, very foreign concept for a lot of doctors to approach fitting this way. Do you believe that the corneal GP is inherently uncomfortable, but some patients are going to tough it out for the payoff? If you believe this, you have to go back and retrain yourself because this is not the case, and you have to get yourself into a better mindset. Do you believe that Wave will successfully fit the lens for you? A lot of people come to Wave and think they're going to shoot a picture, hit a button, and out pops a lens that works. And anyone who's dove into Wave knows it does not work like this. You really do need to understand basic principles behind fitting, basic principles behind Wave, and understanding topography, which we're going to go through a little bit tonight. Do you take your own topographies? This is an incredibly crucial question for you to answer. The majority of doctors delegate out topographies to staff, and this can be the first source of why things don't work properly for you. I take my own topographies, so I know that they're trustworthy, and you will see tonight why that is important to have trustworthy topographies. And if this is something that is not possible for you to do in your office, and you are going to have technicians do this for you or other ancillary staff do this for you, you really need to provide proper training for them so that this way they can deliver proper topographies to you. Do you understand how your topographer collects and processes data? Understanding how the instrument works is really vital to being able to get data that you can find and believe trustworthy. Do you feel comfortable in the computer environment? We have a lot of doctors who are sort of computer averse, and that's a little bit problematic. You have to be able to feel comfortable working within the computer's realm. And do you believe that the perfect lens design on the Wave screen will deliver the perfect clinical result on the eye? After seeing all the consultation that I've done for over 20 years now, I can tell you that one of the battle cries that I hear from the doctor who has failed miserably says, but it looks great on the wave screen. I don't understand. Why didn't this work clinically? And very, very last, do you know what the 3 targets are for successful contact lens fitting? If you don't know what your targets are, you're not going to hit your goal. All right, so let's move on. And I enjoyed this video. That's why I know a lot of the doctors feel like they just didn't quite make it into the pool. So this series of webinars should give you direction by laying a foundation of fundamentals and enables you to approach WAVE with a confidence that you know what you're doing and a direction so that you know where you're trying to actually head to. And this all really starts with topography, so we really need to go over some of the topography basics. So let's start with the WAVE flow chart so we understand how things work. Nah, just kidding. This isn't really how WAVE works, but I really like this graphic. All right, we start with the topographer, and the topographers that currently are compatible with WAVE are Scout, Keratron, and Piccolo. Those have been the longest running topographers that have been compatible with WAVE, and now apparently they are we're losing support on those, so they will eventually be phased out, but they still currently are utilized. Many of you out there have those, and I still use my Scout. The Medmont, a lot of people are using the Medmont, and there are subtle differences between the way the Scout and the Medmont talk with WAVE, and so it's important to understand those subtle differences. The Oculus Keratograph, both the 5M, the 4, and the EasyGraph are all compatible with WAVE, and again, that talks to WAVE actually in a different way. The Pentacam, Basic, HR, AXL, and the AXL WAVE are all compatible with WAVE. For the CSP software, the standard software is available on the Basic and the HR, and the Pro software is on the AXL WAVE. None of the CSP will run on the AXL. And then the future WAVE plans on integrating actually more topography platforms such as the eaglets, so some of the other devices out there will be added in as time moves forward. And then a lot of people don't know, but WAVE actually can stand alone, and you can design up a lens purely from creating a simulated cornea and then designing a lens to match that simulated cornea. We're not going to get into that tonight at all, but that is contained within the software. All right, so let's start with the maps that we're going to take for topography, and I cannot stress this enough. Good topography is vital to you getting a lens that's going to work properly. The lids must be out of the picture. Lids change the data that's processed, and you may or may not pick up on the way that the data is being changed, but guaranteed WAVE will pick up on it and deliver a lens that does not fit properly. So make certain that lids are out of your picture. You're only interested in the corneal data, or if you're doing a CSP, it's the corneal and scleral data, not lids. Good tear quality is necessary. This is true for every topographer except the Pentacam, which is not really tear dependent, but the other placido disc-based systems are tear film dependent, and as a result, the reflections that come off of the surface of the tear film is going to play a role on how the data is processed by your topographer, and if you have poor tear quality, you're going to have poor data. You need proper operative training, whether it's you who are taking the topographies as the physician, or like I said, it's being delegated to the staff. Whoever is doing the topographies needs to have correct training so that they know during the captures that these captures are actually good, reliable data that's trustworthy. You must calibrate your devices at the beginning of use. And you should be able to see repeatability of maps. The topographers will have some place in their software where you can put up one map against another and make sure that they look similar. And then after you've done all that and you have good repeatable maps, you have to pick which map looks the best so that you know which to launch your WAVE design from. All right, so let's take a look at possibly bad maps. This is about the lids, and this is too much lid that's interfering with topography data. You can see on the one on the left, you're missing data altogether, and then on the one on the right, Notice how the inferior lid has given you some flat corneal data right up over here. This data over here actually gets added into the data stream that's processed as it's exported out into wave, and that will be averaged into what this peripheral cornea looks like. And so you can imagine that this very, very flattened data that's showing up over here because it took it off of the lid, this is going to skew the flatness of the peripheral cornea. Okay, let's take a look at this one. Here's another one with lids interfering with the actual captured data. And this right over here, you can see that there's this very, very steepened arc down here. I guarantee you where that's coming from has to do with this lacrimal lake that's right over here. You can see it subtly in the picture. The tears had sort of accumulated down here at the bottom. It bunched up a little bit, and it skewed all of this data. Let's take another one of these lids here. Once again, we have all of this erroneous data being entered in, and it's not just this data down here, but it's more than likely this arc that's over here as well has actually been skewed by this lower lid being in the picture. Up on the top, we're just missing data altogether. So there's not a whole lot of captured data there to begin with. And let's see, on another lid, this is on the Medmont platform. And once again, you can see that we're missing a fair amount of data on the top. We don't really know if this data is actually skewed up over here, and we're definitely missing a whole lot of data on the bottom. One of the other problems with the Medmont platform is very typically even average corneal sizes, but certainly larger corneas, tend not to display on the horizontal. It's very hard to see the limbal area on the horizontal captures of the Medmont, so you have to bear this in mind when you're taking a look at the data that the Medmont is feeding to you. All right, here's a keratograph map, and this was used for troubleshooting an ortho-K treatment map. So we take a look at this map, and we see we have pretty decent capture on these rings over here. They're fairly consistent over here, and this was the process data. So we have to say, is this a good map? And the question is, I'm going to leave it out there for a moment. Let's take a look at this one. Here's another one, and these rings look a little bit like they're skewed. You could see they're a little bit further apart over here than over here, and we have this treatment map. So is this a good treatment map? Well, if you just took a look at this map, you might say, oh, well, my right eye's treatment here is very, very nasally displaced, and my lens really isn't doing the job it needs to do centrally. This one here was sent in from a Pentacam user, and the concern on this particular map was that this cornea looked a little weird because it had all of this flattened and steepened area up over here. And so the question that I received was, I don't know if this is a good case for ortho-K because it looks like it's sort of a weird cornea. This was another one of the captures, and you could see this cornea is just as weird, if not even a little bit more weird, because it's got this very, very steepened arc that's going on over here. And over here, we're up in the white range. Up over here, it's extrapolated data. You could tell that by these little dots that are showing up on the screen. But you can see that we're up at the white range, which is a very, very steepened cornea up in the 67 diopter range. So let's take a look over here. Here's the left eye, and again, this cornea looks a little weird. On this left eye, we have this blip, this red blip here. We have some flattened zones up over here. So again, the cornea is a little weird looking. And we come over here and we have, I'm sorry, I displayed this right one. That's an error on the screen there. But I did go ahead and put a comparison of the three right eye captures over here. And I did a difference map on the first one, this A map, and the C map, which is this one down over here, to show the difference between these two captures. Now, this is the same exact patient. And take a look at what this difference map shows. And we could see that we have a range of error that's in the white range up over here and over here, which is at 21 plus 21 diopters. But we're also down in the darkened range here, somewhere around the minus 15, 16 diopters. So we actually have a range showing a difference here of better than 35 diopters difference in curvature. And these were taken virtually here, 11:56, 11:59, within 3 minutes of each other, 3.5 minutes of each other on the same eye. Well, you already know that this data is very, very untrustworthy. So I'd like to go back just a moment at those previous slides and take a look for a second and look at what was giving rise to some of these topographies. Notice this image over here where this eye happens to be looking. We can also see up over here that this eye sort of looks tilted. Anyone who does pentacam scans knows that this should be kind of more in a straight plane, and we really should be seeing the arc of the cornea sort of at an even height, both on the left and the right side. And so really what gave rise to a lot of this false data had to do with really the fixation of the patient. Or I should say better, the operator was not paying attention to where the patient was fixating and gave rise to these erroneous data that was captured. And if you, the doctor, were just given this data and didn't happen to notice this type of thing, such as the doctor who sent this case in for consultation, you're sitting there stymied because of the fact that, well, I don't know, there's something weird about these corneas. All right, let's move forward. Okay. And there's the left one. Okay, now we have lids and tear debris. Now these maps here were actually taken on top of a GP that was on the lens, on the eye. So we're actually seeing the front surface of the lens being mapped out by the topographer. So what's wrong with this? Well, I can tell you that all this right here and all this right up over here is all junk and debris that's floating by and giving rise to an apparent steep area that obviously is not so steep, but it's actually just the junky tear film that's floating by on the contact lens surface. And again, this illustrates very, very clearly how even though we have a totally homogeneous front surface that's been manufactured onto this lens, the data that's being displayed does not show that. Okay, let's move on. More lid and tear debris, and again, the same type of problem. This is all debris that's just floating by on the lens. And bear in mind also that if this patient is complaining that the vision's fluctuating, you have obviously the reason why behind that sitting right here on this topography. The surface on the front of this lens will not refract light properly or consistently if this type of debris is floating by on a regular basis. And this can be the reason why your patient's complaining that they're not really seeing well out of that lens design that you had done so meticulously for them. Now, let's move on here. More for the tears. We can see here that the placido disc rings don't really look continuous. We have a little break in the ring here. We have breaks in the ring here, breaks in the ring up over here. We can see here it's kind of been, looks like it's smeared. On this one, we're missing a whole lot of data throughout the entire center, as well as what's going on over here. So just looking at the tear film through these reflected rings gives you a qualitative assessment that there's probably something not so trustworthy about this test data. This one's total operator error. What happened on this one here is that the operator jiggled the topographer. This was probably done on a handheld scout, and as it was capturing, it looks like the topographer was moved from left to right a little bit, and that's what's giving this sort of smeared look to the rings as they're moving from left to right. All right, so let's take a look. Now that you're experts at looking at bad maps, what's wrong with these maps here? Well, the one that's here on this left side of this right eye, certainly we can talk about the fact that this upper lid's in the way, and this red arc may or may not be truthful as far as what's going on this eye. This left one, I don't know. We did pretty good up on the top over here. The bottom might be a little bit questionable. But are these good or bad maps? Would you design a lens on these? Let's move forward. All right. What about these maps? All right, so this one looks like it's pretty good. We have a decent capture of rings here. There's a little bit of dropout over here, but for the most part, that looks pretty good. And what's going on with this? Well, it looks like we have a little bit of inferior steepening on this map here. Other than that, it doesn't look really too bad. We certainly do have a little bit of lid in the picture here. Ideally, we should see the limbus all the way around, and this is possibly an issue that we need to take into account. Let's move on over here. What's wrong with these maps? Well, this one, we did pretty good with the upper lids out of the way. We didn't quite do as well with the lower lids out of the way, and we could see we got a little bit of noise over here. But other than that, would you say these are trustworthy maps to design from? Well, you might be feeling pretty comfortable with these. These don't look really all that bad. So let's take a look. And I put them up here. Oh, I'm sorry, this is one more map. I'm sorry, I forgot that I had this one. Here's another carograph map. This is a little bit of a strange one because it looks like it's a superior cone almost, because we have all this superior steepening. All right, so let's go over here and take a look. So this was the first set of maps that I had put up previously there with the Scout. And we commented about a little bit about these upper lids, upper lid here and the lower lid here. This one not quite as bad. And here's the second map. And on this set over here, we said we did pretty well on the upper lids. And lower lids, we did fair on here. We might have a little bit of an issue here. The problem is that this is both the same patient. So the difference in how the algorithms of the topographer process this data are very, very different. The reason they're different is having to do with these lids that have come into the picture, and it has changed how the algorithm has added all of the processed data to show back the actual curvatures that it's measuring. And as a result, we can see just by these colors that we probably have about 3 diopters or so more steepness to this first set than we do on the second set. Furthermore, this inferior steepening looks a little more dramatic on the second set than it did on the first set. I don't know that anyone would have actually picked up on that over here. This one possibly. But here we have a little bit more inferior steepening. So now the question really is, which one's the truth? Because we're talking about a dioptric difference of probably about 3 diopters based on just these colors over here. How many people would fit a cornea that measured on keratometry at 42 by 4250 a little differently than a cornea that measured 45 by 4550? I think we would approach those very, very differently, and you certainly would approach these very differently in WAVE. Interestingly, these maps, both the top pair and the bottom pair, showed good repeatability. So the operator was able to get bad data repeated through every map. And so you then seeing the data that was collected totally removed from the patient. Maybe you took this data into your consultation room where there's no patients to sit down and design up the lens, and you think you have relatively trustworthy data, and trust me when I say you're going to get a pair of lenses that do not fit like you expect them to if you're starting with data that's this far skewed from the reality. On the keratograph pair, we said this one didn't look too bad. It looked like it's a reasonably decent coverage and of decent quality, and possibly a little bit of inferior steepening. And once again, this is the exact same patient, and you could see that if you're just looking at these color maps, these look very, very different, and they will look very, very different to WAVE as well. So you will get very, very different lens designs using either one of these as a source topography for WAVE to design from. And so it's obvious what the problem is here is that this data error is really problematic, and it's going to give you bad data to start with. All right, so now, what about these maps? Well, you've been listening to me tell you about getting the lids out of the way, and you could see that these are really nice. The lids aren't in the picture at all, and this really is what it should look like. So what's wrong with this picture? Any ideas? Take a look. All right, we have a little bit of a steeper eye on this side than we do on this side, but for the most part, I think we would agree that this is probably reasonably trustworthy. Data error here based on calibration. Notice how this right and left eye have the exact same little blip, steep and flat zone in the exact same location. I guarantee you where this came from was from probably a piece of dirt or something that was on the calibration sphere for this particular calibration that was done, and that has now translated into all the maps. So you have to be very, very discriminating when you're taking a look at these maps and looking for the data and making sure that the data all makes good sense. All right, what about repeatability from one map to the next? Well, it certainly gets a lot more challenging when we have to deal with irregular corneas such as this particular eye is here. We could see here that certainly it's a very steep central cornea, it's probably keratoconus, but how repeatable are these? Well, on the Scout, that looks like this, where it does repeatability, and notice that even though it's checking what would be equivalent to keratometry data, it's showing roughly a diopter and a half of variance between these maps. Well, again, that's a very, very large difference. And so these are not really trustworthy maps. We don't know which one is the closest to the truth. And yes, it does get more challenging the more irregular the cornea is. So what to think about selecting when you're selecting up a map? So the first one is there good corneal coverage? As we saw in many of the slides presented tonight, that we need the cornea really exposed to the topographer so that we have the entire cornea really being measured as best as possible with no lids in the picture. The next thing is, how well are the Myers positioning on that particular cornea? On some of those keratograph maps, we saw how they were skewed a little to one side or the other, and how the processed color image really reflected a very, very different outcome in terms of the data it was presenting to you. So we have to make certain that the Myers are positioned properly so that the algorithm that's within the topographer can process the data properly. Okay, is the tier quality acceptable? Again, other than the Pentacam, this is an incredibly important question to answer, and you might want to go back and look at the raw photograph in addition to the color map to make certain that the tier film looks like it was acceptable. How repeatable are the maps? Are they looking really all to be in agreement with each other? And for the newer people who are out there, I highly recommend get manual keratometry done in addition to the topography. The manual keratometer and the simulated Ks that are on the topographer should be in agreement within a quarter diopter. So, for example, if you're measuring up on the manual keratometer a 44 by 4450 cornea, and your sim Ks are showing 47 by 4750, you have a problem. There's clearly something wrong somewhere. And manual Ks are relatively easy to do. There's a lot less that can go wrong in the process of taking those. And so I highly recommend, especially at the beginning, while you're learning how to be discriminating about which topography you're going to utilize for a design, go ahead and get manual keratometry and compare it with the simulated Ks and make sure that they're actually in agreement. Okay, and once you've done all that, you have a lot of confidence in that map that you chose. This is typically what my screen would look like. I put everything up all at the same time so I can get a sense of what the processed image looks like, what the raw image looks like, what's the quality of the rings. Are they distorted? Are they continuous? How does everything look? And then check the repeatability, and we could see here, this is less than a quarter diopter of variance here, so we have very, very good correlation from one map to the next. And so, based on that, which map would you choose here? Which one looks the best? Okay, well, we can quickly eliminate this one here because we could see that we have erroneous data from this lit up over here. This one as well is suffering both on the upper lid and possibly also a little bit of a lower lid. So it really comes down to these first two that we have processed over here. And of these two, which one looks the best? They're corresponding to these maps over here. If I was picking these two, I would actually pick this one right up over here. This is the one I feel the most trustworthy of the truth out there. Okay, so to review, we really need good maps to start. Things can really go off the rails very quickly if you have poor maps. Interestingly, anecdotally, I'll just share a story that happened to me just today. Last week, I had done a capture with the Pentacam, and I noticed that the auto capture had the eye aligned very far off what I considered the central visual axis. But that was the only place that the Pentacam actually captured on this eye. Now, on the other eye, it captured it perfectly centered exactly where I expected it to be. And so when I took a look at the map, I was very, very suspect of the data that it had provided to me to design up the lens. However, this particular eye that showed the skewed capture point is an eye that best corrects to 2400. The bar is very low for me to get a lens on that eye. So I said, oh, you know, just as an exercise, let me just design a lens from this data that I feel is tainted. And so I went ahead and designed up that lens and put it on the patient today. And that lens had to be the absolute worst fitting lens I have seen behind my biomicroscope in at least the last 10 years. That's how poorly that lens fit. And so clearly this was all related to the original design being skewed because of the fact that the topography was designed right from the start, and I mean was bad right from the start, and it gave me bad data to start with. And that's despite my knowing what to do with wave, it didn't matter. You still end up with a bad fitting lens. So the importance of this good topography cannot be overstated. It really is very important to become critical and discriminating about getting good topographies to start with. And if you are not the one who is taking the topographies, it puts you at a disadvantage because you were not part of the actual capture process. And so you have to be even more discriminating when you go ahead and are given these maps in isolation of seeing the patient, kind of like if you were doing a refraction and you didn't hear how the patient responded to the difference of a quarter diopter. Sometimes you'll put the extra quarter of minus up and they will be, oh yeah, that's very sharp. And you can hear in their voice, they went from a sort of a sluggish 20/20 to a crisp 20/20, whereas the other patient was, you know, a sluggish 20/20, and maybe they got 20/20, but they were still very sluggish, and the quarter diopter didn't make much difference. If you're not there to hear the response from the patient, you have a little bit tougher decision making. Does the patient really need the extra quarter diopter or minus? Well, in much the same way, if you're removed from the topography captures, you have a little bit tougher time understanding the trustworthiness of the maps and whether or not they really are good for design. And so you absolutely need to teach whoever is going to be doing the topography enough proper training so that they can be discriminating during the captures. And then you, when you sit down to design up a lens, even need to be more discriminating and critical of those captures to make sure that they really do look proper. Okay. Obviously, lids must be out of the picture. Tear quality is a very, very important issue. We need the operator training, as we talked about. It definitely needs to be calibrated properly. And we should see repeatability of the maps. And then you have the trouble of going through and sifting out which one is going to be the absolute best map that I can use so that I'm going to get a lens that's going to do what I want it to do. Remember, GIGO, garbage in, garbage out. It all starts with topography. For resources, you heard me mention about my private consultation services, and I offer 5 of them. Down in the lower right there, that's the website address where you can find out more information about these consultation services. Basically, they are being provided so that You can advance your learning to a much higher level of complexity. I am not bound by FDA regulations, and so anything that's going to be off FDA, I can still certainly cover in the private consultation. And yes, the services that I offer are for the people who are really looking to get way beyond the Waves help desk in terms of case. So the 5 options that I offer are case-by-case help. Now, typically, this is intended sort of a learn-as-you-go. Basically, as a case presents itself, and you feel that the case may be a little bit over your head, you can learn how to take on that case and proceed to deal with that case while I do the case for you and get your patient successful. And so you get to learn the knowledge as the information that you need to learn is being presented to you. So that has the advantage of sort of bypassing the going to a lecture, learning 37 new facts, and then not encountering them for 6 months, and then you don't remember any of them. This is really a learn as the information is needed, and so you get to learn how to approach that particular case, and you also get that case successful. So that's the first avenue of help. The second one is phone help, and typically this is targeted more for specific cases or to bail out a case. The majority of the people who have been using phone help will book time with me, and it's because they have a case they took on, the case didn't go quite like they wanted it to, they don't know why it didn't go like they wanted it to go, and they need to have a direction as how to move forward with this case and bail out the case. So typically, that's more of what the phone help is. So it's more targeted for a very specific case, bail out the case, or a specific problem that was encountered on a case. There's the one-on-one personal time, and yes, due to COVID, that has been slowed down considerably, but that's typically where we work in person, full day or 2 full days. I won't do more than 2 full days consecutively because, quite honestly, it's just too much information. But that's targeting more of a specific weakness that the individual has and the goal that that individual wants. For example, you might have a practice that's devoted to keratoconus, and you have a lot of questions on keratoconus, and Wave should be solving your problems, but it's not, and you want to get better at dealing with keratoconic corneas. We will spend an entire day talking about keratoconus, everything related to keratoconus, and how you need to approach these cases with Wave so that you can design up successful lenses. Design and supply are really meant for the non-Wave docs. This is really where I will do, kind of like on the first option with case-by-case help, I will do the case for the doctor, but it's a non-Wave doctor who has no Wave account. I will supply the lenses in addition to doing the case for them. The few doctors that I've done that for have, they were not really interested in learning Wave. They were really interested in just getting a patient successful, and they felt that Wave might be able to do that for them. It did do that for them. And then very, very last is I still have DVDs. There's not too many left, but DVDs from the Wave Winter Weekend Workshop I had done a few years ago. Even though it was a couple of years ago, the information is still very, very relevant to what you guys are needing to understand. It's about 16 hours of index material that I had presented. It's over the 8 DVD set, and it really ranges over entire theoretical concepts to clinical applications. It covers, for Wave, ortho-K, Scleral lenses, irregular corneas, etc. If you do make your way onto the consultation page, you will see that there's a place to see the DVDs, and they are broken down to the actual topics and what's on each of the DVDs, so you can get more information about what's contained on the DVD sets. As far as the services that are available from Wave directly, you have the Wave website at wavecontactlenses.com. You have the waivers page, and on there, that's password protected, and you can get all that information from Wave. For clinical support, the lens order service, the user's guide, so you might need to download that from there. There's Wave Academy, the technical support, and also the link to IO so you can check the online orders. The resources page is open to anyone through webinars, videos, events, and these webinars will eventually end up showing up over there as well. And then there's the Wave Users Google group, which is really just a discussion forum where we share topics, and some doctors can help some of the other doctors through some problems that they run into at the, on a specific case, or the topics can range from anything to what solutions you use to even how to manage, like a practice management type of case, as well as to how you can better do what you need to do in your office. Okay, so with that, I'm going to wrap up tonight's presentation. Thanks everyone for attending, and I hope to see you next month. Have a great day. Bye-bye.